The very first planets we ever discovered outside our solar system. They don't orbit a star like our Sun, they orbit a corpse. A dead star. And not just any dead star, a pulsar. This is the collapsed, crushed core of a star that exploded in a supernova. It's an object spinning hundreds of times every single second, blasting the universe with twin beams of deadly radiation. And somehow, impossibly, planets survive this cosmic cataclysm. These are the pulsar planets, the most extreme, most hostile worlds we have ever found. They are the silent witnesses to the death of their own sun. So what exactly is a pulsar? Imagine a star, much more massive than our sun, reaching the end of its life. It runs out of fuel. Its core, no longer able to support its own immense weight, collapses in on itself. The pressure becomes so unbelievably intense that protons and electrons are literally squeezed together, crushed into existence as neutrons. What's left is a neutron star, an object with the mass of our sun, but compressed into a sphere the size of a city. If you could scoop up just one single teaspoon of neutron star material, it would weigh 1 billion tons here on Earth. And this stellar remnant, it spins incredibly fast. Some pulsars rotate hundreds of times per second. As they spin, their powerful magnetic fields generate intense beams of radiation that shoot out from their magnetic poles. Think of a cosmic lighthouse. As the pulsar spins, these beams sweep across space. And if one of those beams happens to sweep past Earth, our radio telescopes detect a brief, regular pulse of energy, hence the name, pulsar. Back in 1992, two astronomers, Alexander Volshan and Dale Frail, were studying a pulsar named PSR B1257+12, about 2,000 light-years away. They noticed something strange. The pulses weren't perfectly regular. They were arriving a little early, then a little late, in a predictable pattern. The timing wobbled, ever so slightly. And that wobble could only mean one thing. Something was tugging on the pulsar, pulling it back and forth with its gravity. They had found planets, 3 of them, to be precise. These were the first exoplanets ever confirmed by humanity. And they were orbiting a dead star. This discovery shattered everything we thought we knew. A pulsar is born from a supernova, an explosion so colossally violent it should destroy everything in its vicinity. Any planets that were originally there should have been vaporized instantly, or at the very least, flung out into the darkness of interstellar space. But these planets were there, quietly orbiting the corpse of their star. So how did they survive? There are 2 main theories. The first is that they didn't. The original planets were indeed obliterated in the supernova. But some of the debris from that explosion, the shattered remnants of the old system, didn't escape. Instead, it formed a new disk of dust and gas around the newborn pulsar. And from that disk, a new generation of planets formed, born from the ashes of their predecessors, second-generation planets. The other theory is that these planets are cosmic nomads. They were captured. Imagine rogue planets, cast out from their own star systems, drifting aimlessly through the galaxy. By sheer chance, they wandered too close to this pulsar, and its immense gravity ensnared them, pulling them into a new, permanent orbit. Either way, these are not your typical worlds. So let us imagine what it would be like to stand on the surface of one of these pulsar planets. First, you'd have to contend with the radiation. Pulsars are fire hoses of high-energy particles, X-rays, gamma rays, particle beams, all washing over the planet constantly. If you stood on the surface, you would be sterilized and killed in a matter of seconds. Your cells would be torn apart by the relentless bombardment. No atmosphere could possibly protect you. the radiation would strip it away, leaving the surface bare and exposed to the cosmos. Second, the light, or rather, the total lack of it. A pulsar is not a star in the traditional sense. It emits vast amounts of energy, but not in the visible light spectrum that our eyes can see. So, if you stood on a pulsar planet, the sky would be an eternal, inky black. There's no sun, no warmth, no gentle glow. Just absolute darkness, and every few milliseconds, as the pulsar spins, an invisible flash of radiation would sweep over you. It's like being in a strobe-lit room, but the light is one you can't see, only feel as it rips through your body. Third, the silence. Out here, there's no solar wind, no crackling stellar flares. There's just a dead star, spinning, pulsing, an utterly silent, rhythmic beat in the void. And the planets orbit in that profound silence, dead worlds circling a dead star in a cosmic graveyard. Now, the big question: could life exist on a pulsar planet? Almost certainly not on the surface. The radiation is far too intense. The absence of a sun means no photosynthesis, no source of warmth, no stable energy for life as we know it to take hold. But what if life existed before the supernova? What if organisms were living deep underground, perhaps in subsurface oceans or vast cave systems, shielded by kilometers of solid rock? They might have actually survived the star's death. They would never even know their sun had exploded. They would continue to exist in eternal darkness, warmed only by the leftover heat from their planet's core. Never seeing the sky, never knowing about the deadly pulsar spinning silently above them. Just existing, in the deep, alone. Since the groundbreaking discovery of the planets around PSR B1257+12, we have found a few other pulsar planets, but they remain incredibly rare. It seems most pulsars are alone, just spinning in the void. But the ones that do have planets, they're more than just cosmic curiosities. They teach us something fundamental about the universe. They tell us that planets are resilient. They show us that planetary systems can survive even the most violent events imaginable, like a supernova. They prove that planets can form in the most unlikely of places, from the literal ashes of destruction. They can endure unimaginable radiation, perpetual darkness, and total isolation, and just keep orbiting forever. Pulsar planets also serve as a haunting glimpse into our own distant future. In about 5 billion years, our sun will die. It's not massive enough to go supernova, but it will swell into a red giant, expanding so far it will swallow Mercury, Venus, and possibly even our own Earth. Afterwards, it will collapse and cool, becoming a white dwarf. And if any of our system's outer planets survive that process, they will find themselves orbiting a dead star, cold, dark, lifeless, not so different from the pulsar planets. There's something deeply poetic about these worlds. They are the ultimate survivors. They are silent witnesses to the most violent event in the universe, and they endure, orbiting in the quiet dark, under the watchful, pulsing gaze of their dead sun, forever. This has been Cosmic Terror. Thank you for beginning the new year with the dead and the eternal. Until next time, keep watching the dark, and Happy New Year.